Okay. Class, we have been solving or plotting the qualitative ILD in this course. That we studied some of the basics and solved some example problems related to this topic in the last lecture as well. So in today's lecture, we will be doing some more example for these qualitative ILDs, and then we will move on to learn or study the method about conversion of qualitative ILDs to the quantitative one. So before moving on to that topic, first I would like to solve one or two simple problems related to these qualitative ILDs. For example, let's consider that this is a cantilever beam, and for this beam, you have to plot the ILD at point B for shear force and bending moment. Uh, I'm going to give you 1 or 2 minutes. Can you quickly plot the shape of ILDs for this beam at point B for shear force and bending moment? So, can anyone tell me how will the shape for ILD for shear force looks like for this beam? Naveed.
So just give me a minute, मैं figure out कर रहा हूँ.
Okay, do it quickly. Hasnan, can you hear me?
Yes, sir.
So how will the shape looks like? So, as we have learned in the previous lectures, what were our steps to plot the ILD for shear force at any point in a beam? First, we will divide the beam into two parts at the point for which we need to plot the ILD, and then we will apply a roller guide at that point. And then the third step is we will apply a downward shear force on the left side of that roller guide and an upward shear force on the right side of that uh, roller guide. After applying these two loads, I will simply plot the deflected shape, and that deflected shape will be equal to my ILD. So in the last lecture we also did that. If I am going to apply this upward force on the right side, there is this beam or member of the bar without any support or the free end at both ends. On this end, it can move upwards, but considering this end, there is no support. So the member will move upwards as a whole. So this is its final shape or the deflected shape, and this will be my shape of ILD on the right side of this beam. And what about this left side? How will it look like? What will be its final shape? Anyone?
फिर downwards
Triangle.
जाएगा और triangle होगा.
Triangle रहेगा sir downwards.
Yes, sir.
This triangle, you mean? This one, right? So, do you think that it will move? Do you think it will move like that?
Yes, I do.
Why? Remember that we have a fixed support at this end. Actually, for this end, this beam won't have any kind of displacement, and the final shape of ILD will be something like this. Now, can anyone explain why there is no deflection or no deformed shape at this end of the beam? For example, let's say we were doing when we were solving the question for the case of simply supported beam, and we were plotting the ILD for shear force at this point, we did something like this on the right end, a downward triangle, like for example, if this is the beam and on this end, an upward triangle was formed. Why these two triangles were developing on the two ends? Why? The reason was that because this support, this hinge support, does not allow the beam to move or to displace in the vertical direction. Can you please turn off your mic? So on the left side, this hinge support allows only the rotational movement, but it does not allow the beam to move in the upward direction or in the downward direction. So that's why when the load was being applied in the downward direction on the left side of the beam, it will move down because this hinge support does not restrict the movements or does not provide any resistance to the internal movements that are developed in this beam due to this applied load. Now look at this hinge support, this fixed support. Now this fixed support does not allow any kind of vertical displacement, as well as it also resists the bending moment which will develop in this beam member due to this horizontal force. So that means when this downward loads will be acting on the member, this member won't move anywhere. It will stick to its place. Okay, so that is why when I have plotted the ILD for shear force, there won't be any sort of deflection on the left part of this beam. For example, if I had plotted in this way, what would be the difference in the two? How would you figure out that this, or what's the point of having a fixed support at this end or the hinge support at this end? Actually, this is the difference, that the hinge support allows the rotation. That is why when the load is applied in the downward direction, the beam moves downwards. But in the case of fixed support, basically the fixed support is something like this one. It is completely holding the beam. So when you are going to apply the downward movement, it won't move anywhere. It will remain at its place. But there is another question. For example, in general case, when we were plotting the elastic curve, we were representing the deflection of a cantilever beam, something like this one, or the elastic shape of this beam, something like this one. So from this shape, you may get confused that why didn't we show this deflection of the beam somewhat like this one, as some of you have correctly pointed out that it should deflect something like this one. Actually, Muller, uh, let me show you the slide. Actually, Muller just made a small assumption, or let's say it's just his method of plotting the ILD, that he said that the beam is a rigid member and there is no elasticity in its member. So what does this statement mean? Actually, Muller said that when we are going to plot the deflected shape, we will consider that this member is a rigid member and there is no elasticity. And basically this shape that we were used to plot for any type of beam structure was the elastic curve. This elastic curve is a bit different than the deflection. In the deflection case, or in the case of plotting the ILD using the Muller method, there is no deflection or no elasticity in the beam member. So either the member will deflect as a whole or it won't deflect at all. And which thing play most critical role in this kind of deflection is this support reaction or the reaction or the support that is on the ends of the beam. For example, in this case, we can also show that the beam is going to beam has an elastic curve, something like this. But Muller said that there is no case of elasticity when you are going to plot the ILD. So you just have to consider what type of support is at other end, and considering that support, you have to plot the deflected shape. For example, in this case, this support allows the rotation, so when the load is acting, it will move downward. In this case, this support does not allow anything, no displacement, no rotation. So when you are going to apply the downward load, there won't be any sort of displacement. And this is what we are going to get for the ILD force, shear force diagram at point B in case of cantilever beam. Now, if there is any question about this one, you can ask me.
सर ये इलास्टिक कर्व वाली डायग्राम पर एंड करेक्ट है कि नहीं? ये मुलर की assumption रॉन्ग थी.
Actually, this diagram is correct, but this diagram is correct. Usually, we plot this diagram to show that elasticity of the member, basically. What does that mean? That means that the beam is elastic, although this support does not allow any sort of displacement or rotation, but when the load is applied, due to elasticity, there will be some deflection that will be produced in the beam. So this is what this elastic curve shows. This diagram is correct, but this diagram does not work in the case of Muller method, because he assumed that my beam or the beams or his method assumes that the beam does not have elasticity and it is simply a rigid beam. Okay, in the case of rigid beam, there won't be any sort of elasticity and there won't be any such deflection. Okay, so in that case, these supports plays an important role. We have to look for the support to figure out the deflected shape. So this diagram is correct, but in the case when the beam has elasticity, but in the case when there is rigidity, there won't be any such type of elastic curve. Okay, there will be either a complete deflection or there will be no deflection in this case, and this support will control this deflection. Will you get my point?
Yes, sir.
Okay, so plot the ILD for bending moment at this same point. For the bending moment, what we used to do is we will again cut the beam into two parts at this point and apply two opposite movement. On the left side, the counterclockwise movement, and on the right side, we are going to apply the clockwise movement. And then we will see how the beam will react. Now, as we also solved one similar problem in the last lecture as well, that how will we apply this moment, we will consider this as our pivot point and apply the moment at this point and see how will this member deflect. Obviously, this member is going to deflect something like this in a triangular shape. And on the right side, again, the same scenario will apply as in this question. This beam or this member won't be moving anywhere because this support does not allow any sort of rotation, any sort of deflection. So it will remain as it is. So again, this will be my shape for ILD for bending moment at point B. And this is ILD for shear force at point B. Now, again, I would urge you to go on and solve both of these problems by method of equation or tabulation to confirm or to make sure that you will get the similar kind of shapes by these methods. And after doing this, you will get the idea that how strong this Muller method is. You have to do like 5 or 6 steps to get the answer by this method, and by Muller method in one step you will get this answer and you will get the similar shape by both this method, and that is why this method is very popular, particularly in this field. So any confusion about this one?
सर
Yes.
एक्सक्यूज मी सर,
Yes.
जो मूलर मेथड है इसमें सिर्फ शेप मिलता है या वैल्यूज का भी पता चलता है?
Yeah, for now we are only getting the shape of ILD, but in this lecture also we will be studying the method to convert or to get the values of these ILD as well. This is the qualitative
Yes.
ILD. We will plot the quantitative ILD.
Thank you.
सर
Yes.
सर जो आपने फोर्स सप्लाई की थी पॉइंट बी पे एक डाउनवर्ड सप्लाई की थी और एक अपवर्ड सप्लाई की थी तो
Yes.
इज दैट डिपेंड ऑन अस कि हम लोग कौन सी फोर्स अप्लाई करेंगे या फिर कोई उसके ऊपर पीछे कोई एसओपी है करने के लिए
Yes, actually we discussed in the last lecture as well that for the shear force, we made one sign convention that when we will cut the beam on two parts, we will apply a downward force on the left side and an upward force on the right side. So this is our sign convention. And similarly in the case of beam also, counterclockwise and clockwise.
थैंक यू सर
You're welcome.
सर लास्ट लेक्चर में आपने कहा था कि जो शेप ऑफ आईएलडी होती है वो इक्वल टू डिफ्लेक्टेड शेप ऑफ बीम होती है
Yes.
तो आईएलडी जो बेंडिंग मोमेंट की आईएलडी होती है वो वाली या फिर shear फोर्स की
For both ILDs, because this one is my ILD when I applied the shear force, and this is my deflected shape when I've applied the bending moment. So these are two different deflected shape, and this one is ILD for shear force, and this one is equal to ILD for bending moment.
ओके सर
Is there any confusion? Okay.
सर मुझे ये चीज समझ नहीं आई कि मतलब बेंडिंग मोमेंट में जो जो पॉइंट है वहां पे जीरो क्यों एंड फिर एंड पे मतलब मैक्सिमम कैसे हो गई है मतलब
Okay.
ये बेंडिंग मोमेंट की डायग्राम समझ नहीं आई
We also discussed this in the last lecture, but again I will repeat. For the case of bending moment, how actually does the bending moment is being applied on a member? You usually hold this beam from this point, and then you try to apply the rotation in the clockwise direction. Let's say just next to this point, and just physically, if you have any pen or a pencil in your hand, just hold this pencil in one end and try to rotate it in clockwise direction, and just look at in which direction it is going to rotate or what is its deflected shape. Can you see that it is being deflected in this inclined shape? If you just apply the rotation right next to this pivot point, because the other end is fixed. So can you see that, Naveed?
Yeah, okay sir.
Yeah, it is deflecting something like this one. But in the case that if there is some support at this point, or at the right point, and you are applying this sort of movement, then in that case, this support won't allow it to move downward. So what will happen that this part will move upward. So in that case, this will be the shape. So there is a small differences. So try to solve different problems that we did in the last lecture and this one also, then you will get a strong concept or build a strong concept. Okay, let's solve another question. Or we will solve this question at the end of the class. First, move on to the other topic. Okay, now we can get the qualitative shape for the ILDs, but obviously the qualitative shape is a good indication, but we do need some kind of mathematical value to verify our results or to make them to make these ILDs as useful. So there are some basic steps that we need to follow to quickly get the values and then plot or give the final ILD shape. So that method or these steps include that we need to plot the shape of ILD by using the Muller's principle, and then we need to consider the beam separately and apply a unit load at that point for which we need to plot the ILD and simply plot the shear force diagram and bending moment diagram for that beam. And the values of shear force and bending moment diagram, for example, if this is my beam and I am going to plot the ILD for point P, what will I do? In the first step, I will plot the shape of ILD at point P using the Muller's principle. And in the second step, I will apply a unit load at this point and calculate or plot the shear force. Let's say this is my shear force diagram or this is my bending moment, then these two ordinates of shear force and bending moment diagram are similar to the ordinates of ILD at point B. For example, if my ILD for shear force is something, let's say like this one, then the ordinates of shear force and bending moment diagram, these two ordinates, will be same as, let's say, if this is 0.25 and 0.75 over here, then in my ILD, these two ordinates will be equal, because obviously the ILD is basically the shear force at any point when the unit load is at that point. So for example, if we get the if my unit load is at point P, then the shear force at this P point will be equal to the ILD component at that particular point. And similarly, if this is my ILD for bending moment, then this component of bending moment will equal to this component in the ILD. Now, if I get one component, I will solve the similar triangle. For example, in this case, this is actually the simple ILD. Let's say if this ILD is something like this one also, or connected with some other beam as well. So then if I know one component, I can simply apply the rule of solving the simple triangle and get all the values in that ILD. So this is how we are going to get, or we are going to convert the qualitative ILDs into the quantitative one. So we'll solve one question, then you will get a clear picture of this method. So let's say we have this beam. This beam, actually it's a straight, let me do it again. This is the overhanging part, and this is the roller support. This is point C. This distance is 2 meters, this distance is 3 meters, this distance is 1 meter, and this distance is 2 meters. And now I need to plot the ILD, or the quantitative ILD, for shear force at point C, bending moment at point C, and reaction at support B. This is my A support and this is my B support. So in the first step, what will I do? I will simply plot the ILD for this function by using the Muller principle. Let's say if I want to plot it by using the Muller principle, what will I do? I will simply cut the beam into two parts like this one, and I will apply a downward force at this end and an upward force at this end. So, and plot the deflected shape. So we also solved this question in the last lecture as well. So what will be my deflected shape for shear force? When this shear force is acting, this part will move downward, and obviously this part is the overhanging portion, and it will move in the upward direction. So the shear force, or ILD for shear force, will pass through the support, and in this part, when the upward load is acting, this part will move up, and the right part of the beam will move down. And when I connect these 2 points, this will be my shape for ILD for shear force at point C. Okay. Similarly, if I want to plot the ILD for bending moment at point C, I will cut the beam. Let's say this is my point C. I will cut the beam into 2 parts and apply an opposite moment at these ends. Now what will happen? This part will move upwards, passing through the support, and this part will also move upward, passing through the support. So this is my shape for bending moment at point C. Okay, and what will be my shape of ILD for reaction at point C? Let's say this is my beam, and in the case of reaction, what we used to do, we will remove this support and apply reaction, or the upward vertical force at the point of reaction and plot the deflected shape. So how will the beam move? It will actually move in the upward direction. Okay, so this will be my ILD for reaction at beam. Now I want to get these values. So, but I don't want to repeat those tabulation method or the method of equation because it will take a lot of time to solve this method. So that is why we have developed a short method. We have to do one step of that tabulation method. We will get one component of this reaction and we can plot the ILD.
सर बी
So,
पॉइंट कौन सा है?
B point is this support.
अच्छा फिर
Yeah. So in the next step, as we discuss in the slides as well, Naveed, your mic is not turned off.
I'm sorry.
So let us now consider the beam separately. And plot the shear force and bending moment diagram by placing, for example, in this beam, I needed to plot the ILD for point C. So now I will place the unit load at point C. For example, this is my point C. I will place the unit load at this point and plot the shear force diagram and bending moment diagram. Now, can you quickly give me the reaction due to this unit load to plot the shear force and bending moment diagram? Anyone? What will be reaction at this support?
0.75.
Are you sure? At A support.
सर 0.25 होगा
0.25.
And at this point, yeah, 0.75. So now when I plot the shear force diagram, it will be something like this one. So this value is 0.25, this value is 0.75, and at this and these two ends there won't be any shear force. So this is my ILD for the shear force diagram. My ordinary shear force diagram, not the ILD. And when I plot the bending moment diagram, it will be something like this one. So this is the value at point C. Okay, and this is positive. So now let's move back to these ILDs. We have these two values. Like I said, that at this C point, if we place the unit load, I am going to get some values of shear force for this C point, that is 0.25 and 0.75. Now these two values will be the same as the values of ILD components at this point. So I can simply put these two values on this ILD. Okay. So now I have these two values. I know this distance, that is 3 meter, and this distance, which is 1 meter. This one is 2 meter, and this one is also 2 meter. Okay. So now, anyone, what is this value? What will be this value? And what will be this value?
Point 0.25.
This one will be 0.25
Yes,
on the
sir.
right side. What's something different? I think this one will be 0.5.
सर 0.5 होगी
Because for 3 meter the value is 0.75 and for 2 meter obviously 25% will be lost. So it will be 0.5. So what will be this value?
.5 ही होगी.
It will be same 0.5 because for 1 meter the value of this triangle is 0.25, and for 2 meter obviously it will be doubled because the distance is doubled. So the value will be 0.5.
तो
So
सर
now let
1.5 नहीं आना
yes
चाहिए सर अगर डबल कर रहे हैं तो
0.25 double of 0.25 is what?
अच्छा सही 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 सॉरी सर
Yeah,
ठीक है
because these are my two triangles.
यस सर
So now let's move on to this bending moment ILD. This distance is 1 meter, this distance is 3 meter, and this distance is 2 meter, this distance is 2 meter. So what will be the value at this end? Quickly.
सर एक दफा वो पिछला दोबारा बता देंगे कि
1
आपने
होगी सर।
शेयर फोर्स आपने कंपेयर की है आईएलडी के साथ जो आपने
Yes.
एक्सट्रैक्शन वाली आईएलडी बनाई थी।
Yes.
ये आपने शेयर फोर्स कंपेयर किया, आपने शेयर फोर्स को शेयर फोर्स के साथ कंपेयर नहीं किया, आपने शेयर फोर्स जो सिंपल थी दूसरे मेथड से उसको आपने आईएलडी के साथ कंपेयर किया।
Actually, what is ILD? ILD is basically when the load. Can you please turn off your mic for a moment? Alian.
सॉरी सर
So, actually, what is ILD? ILD is basically, for example, if I want to plot the ILD diagram, ILD is basically the variation of a function. For example, let's in the simple words, I would say that for this beam, this is my shape of ILD. What does this shows? This shows, or this component shows here, that when my load is at point C, this will be my shear force at point C. Or when what does this component show? This component shows that when my point load is at this end, then this 0.5 will be my value of shear force at point C. So it works with reference to a particular point. It does not show the variation of shear force and bending moment for the whole beam. So what did I do when I compared? I basically plotted simple shear force diagram by placing my load at point C. Now my shear force at point C will also be the same as this ordinate of ILD for that or for this point, that is point C basically. So I got this values 0.25 and 0.75 for shear force at point C, and I will simply place this value for ILD for the shape of ILD at point C, because these two are the similar thing or represent the similar thing. Did you understand my point? Ibrahim, I think it was you.
Yes, sir, समझ आ रहा है।
Okay. So in this beam, so can you tell me what will be this value of bending moment?
1.5.
0.5 होगी सर।
0.5. These
Yes,
are
sir.
my two triangles. So for 1 meter, the value is 0.75. Okay. So what will be the value for 2 meter? What is this value? 1.5, right? Did you get it? Zia.
Sir. Yes.
Okay, so what will be this value?
0.5.
1.5.
0.5. So now you can see that in these two beams, I simply solved or got the values of ILD by doing two or three steps, and I have now the quantitative shape of ILD. So this is how you are going to solve these methods. So let's just complete the diagram for reaction at B. We have to do the same step. For example, we are plotting the ILD for reaction at B. We will consider our beam and place the unit load at point B, because now we are plotting the ILD for reaction at B support. So we will place our unit load for point B and compute the reaction at point B. So when my unit load is at point B, my reaction will obviously be same as this one because it is directly acting on this point. So my reaction is 1, that is at point B, and this reaction value will be equal to this ILD value at this point B. So now I have this component 1 at this point, I know this distance that is 3 meter. This distance that is, this distance will now be 4 meter. This distance is 4 meter. This distance is 2 meter. And this distance is also 2 meter. So what will be this component now? Anyone?
सर
Yes.
1.5.
सर ये कंपैरिजन आप किस तरह करते हैं?
What?
ये जो कंपैरिजन आपने की ये किस तरह करते हैं?
Actually, you just need to do simple steps. For example, in this question, I was required to plot the ILD for reaction at B point, right?
Yes, sir.
So what will you do? You will place your unit load at B point and compute the reaction at B support. Okay. So you have that reaction value, and this reaction value is similar to the component of ILD at B point. Okay.
Yes,
And this is what we did in the shear force. For shear force, we were required to plot the ILD for point C. So what I did, I placed my unit load of 1 at point C. I calculated the shear force diagram for the whole beam, but what I need is the shear force for point C, that is these two values, and I placed these values on the ILD at point C. Okay. Did you get my point?
Yes, sir, I got.
Okay, good. So this is my component at this end. And what about this one? What is the value at this end?
0.5.
सर एक मिनट, एक चीज
Yes.
पूछनी थी कि ये जो हमने पिछली डायग्राम बनाई हमने तो उसी जगह पे पुट किया है ना, तो
Yes.
हम सी
But
ये
in
जो आपने
yes.
सी के ऊपर वो नहीं पुट करेंगे, यूनिट लोड और रिएक्शन एट बी चेक करेंगे?
No. For reaction at B, for shear force, we were required to plot the ILD for shear force at point C. For example, these two values at C and bending moment at point C. But for the reaction, we were supposed to calculate the reaction at point B. So at this point, I have to place my unit load at the point for which I need to plot the function. For example, in this one, for example, there will be different ILDs, one for shear force at point D, E, F, or whatever. But there are only two types of reaction, A or B. Okay. So if I need to plot the ILD for reaction at B, I will place my unit load at point B. And if I am supposed to plot the ILD for point A, I will place my unit load at point A. Did you get my point?
Yes, sir.
So this is actually, this will dictate that where I am going to place the unit load. Okay.
सर
Yes.
और आप काइंडली बता देंगे कि आईएलडी कैसे बने, मुझे ये समझ नहीं आ रही.
Which one? This one?
ये रिएक्शन एट बी वाली, मतलब सॉरी आईएलडी. हाँ जी.
Reaction at B, this one. So actually what we studied in the last lecture as well, for the shape of ILD for reaction, what we have to do is we simply need to remove the support. For example, I was supposed to plot the ILD for point B. I will remove the support at this is my point A and this is point B. I will remove this support and apply a vertical force and simply plot the deflected shape. Now you have removed the support. There is only one support, that is this hinge support. So what will happen when I apply the vertical load? This beam will move up from this end, just like the seesaw shape. And on the right side, on the left side, it will move downward. So this deflected shape is my ILD for reaction at B. Did you get it?
Yes, sir.
Sir?
Yes.
So what about the load that acts on B? मतलब हमारे पास B पे support भी है और जो ऊपर से जो load act करता है उसकी वजह से इस तरह seesaw में से like support पे 0 से गुजरती है, तो सिर्फ वहाँ पर ऐसे क्यों नहीं गुजरना चाहिए B पर?
Actually, there was a lot of disturbance. Can you repeat your question again?
Sir, yes. B पर हमारे पास एक support है और B पर हमारे पास एक load भी act कर रहा है.
Which load?
So
this one?
ऊपर से 1 वाला
when is it acting? Where is it acting?
sir on V
Where did I show it?
sir
Actually,
you tag-
there is a difference now. Yeah, this there is a difference. When we are
yes
doing it by Muller method, let's assume there is no other load. Muller method is simply to plot the deflected shape and take it equal to ILD. Okay. So what we have to do is we simply need to we develop some principle or some methods in the last lecture as well. So what we need to do for the support case, we have to remove that support, apply the vertical force at a point under consideration. For example, in this case, the B point, and plot the deflected shape. Now I get it that you are talking about this unit load, right?
yes sir
So yeah, this unit load or this case is true when we are plotting the ILD by using the method of tabulation or by equation method. That method is a different method compared to the Muller one. The final answer is same, but the method is different. So in that method, what we were doing is we were placing our unit load at different points. For example, at first my unit load was at, let's say, this free end or this overhanging end, and then my reaction value, let's say, is 0.5, and this will be one component of my ILD, or let's say this is 2.5. This will be my this 2.5 component, and then I will move on the unit load. For example, then I will place my unit load over here, and I will get let's say 1.5 value. I will plot this 1.5 under this point. Then I will place my unit load at this point, and I will get this reaction, let's say, as 1. So I will plot 1 over here. Then I will place my unit load here. Again, I will calculate the reaction at B. Let's say I'm going to get 0.5, so I will plot 0.5. I will place my unit load over here. I will get the value as 0. So I will say that my ILD for reaction at B is 0. So that method of unit load is different. I will finally place my unit load over here, get the value, let's say, minus 1.5 maybe. So I will plot minus 1.5 over here. And this is how I'm going to get the shape of ILD by tabulation method or method of equation. So basically, both of these methods give the same result. Don't confuse with these methods with each other. This Muller method is just to get the qualitative shape, and this tabulation method is to get the quantitative shape. Now we are considering two methods together to get the shape in one or two simple steps. Okay. So now, uh, is your question or confusion clear?
yes sir thank you sir
Okay. So
सर वैसे
yes, yes.
सॉरी सर सर बात काट रहा हूँ सर क्या कहते हैं एग्जाम में आप what would you prefer, the Muller method or the tabulation method?
I expect you to know all the methods.
अच्छा.
And it depends. I can give you a question which may require the knowledge of all the methods to get the final answer. Because, for example, even in this simple question, you can see that I use both of the methods to get this final value. So basically, what Muller method did, it gave us the shape before solving the question. So now you have the idea and you got the answer in 2-3 steps. But if you start solving it by method of equation or method of tabulation, it will take some time to get the final answer.
Yes, sir.
So that is why I expect you to know all the methods. Okay?
All right, sir. Thank you.
Yeah. So basically, this was the question. Now, I am going to show you one or two tricks to further avoid doing this method of tabulation. But these tricks are just for your practice case. I don't want you to do it for every case, but I just want you to know it, just so that you can, if you want to solve it quickly or if you want to get the values quickly, you can apply these tricks and get the values even one step. I was reading a literature, and in that literature, I found one simple method to get the quantitative shape. You don't have to do any tabulation method or any Muller method. You will simply get or directly get the quantitative shape. For example, this was our beam, right? And if I want to plot the ILD, And remember that this is not related with the upper question. This question is finished. We have got the answers for this question. So if I want to plot the ILD for shear force at point C, this one person, I don't know his name yet, but I will try to find out. He said that you need to plot, for example, this is my point C, and if I want to plot the ILD, let me make it more clear. This was my beam. This distance is 3 meters. This distance is 1 meter, 2 meter, 2 meter. Now this person said that if you want to plot the ILD for shear force at any particular point, let's say at C point, then what you need to do? You need to apply, or you need to plot a positive 1 ordinate at the left side or the left support of this point. So I have plotted a positive 1. And on the right support of that point, you need to plot -1 ordinate. Okay, you did that. So then what you need to do is you need to plot two parallel lines passing through the supports. So one line is this one, and the other line is, for example, if I plot a parallel line to the above one passing through the support, I will get something like this one. Okay. So now this person said that you can remove these two extended portion and before removing these extended portion, you need to connect these two lines at that point for which you need to plot this pen is not working. So before removing the extended portion, let's say this was my point C. So this person said that you need to combine these 2 points. After you have combined these 2 points, you need to remove the 2 extended portion. Let's say I have removed this extended portion and this extended portion. Now the remaining shape, for example, this shape, will be the shape of my ILD. And this shape that I have shown with the red line. And these extended portion on the left side of this connected line and on the right side of this connected line, I will remove, and the remaining shape will be the shape of ILD. Now let's say I have this value 1 at this point. So what will be this value? By simply solving the similar triangle. Can anyone tell me that? Anyone? So this value is 0.25 by solving the similar triangle. And what will be this value? This value will be automatically 0.75, because for 4 meter the value is 1 and for 3 meter the value is 0.75. Now you see that you have got these two values and you can quickly solve it and get the other values of this ILD. So isn't this method interesting?
सर लेकिन इसमें आप एक और पाथ भी तो ले सकते थे कि आप उधर जहाँ पे आपका हिंज सपोर्ट है वहाँ से आप डायरेक्टली नीचे आने के आप ऊपर भी तो जा सकते थे जहाँ पे वन है।
What do you mean? I didn't get it.
सर आप रेड लाइन को डायरेक्टली नीचे ले आए जहाँ पे 2 मीटर वाले डिस्टेंस से।
Here? At this point?
Left side.
So what do you mean? Where should it go?
सर बिल्कुल लेफ्ट साइड पे जहाँ पे हिंज सपोर्ट है वहाँ से आप ऊपर क्यों नहीं गए? यस सर।
Where? Like
ऊपर जो डॉटेड लाइन है।
I told you that on the left side of this point, you have to exclude these lines. So after plotting these parallel lines, these lines are no more there. So we are only left with this one. And at support, you have to pass through the support. You can't show something like this one. Did you get the idea? Actually, it's just a method that has been developed based on the experience. It's not the final word, so we have to apply some basic concepts to get the final shape. But it's a quick method anyway. So after I connected these two, yeah.
तो हमें कैसे पता होगा ये कौन सा एक्सटेंडेड पोर्शन है? आपके एक्सटेंडेड पोर्शन रिमूव करना होगा।
Extended portion, the portion on the left and right side of this connected point. For example, first I plotted these two parallel lines, and then I connected these lines at this point for which I require my ILD. And on the left side, I removed this line, and on the right side, I removed this line. Okay, so the remaining shape or the line is my ILD.
सर
Yes.
सर ये जो 0.25 और 0.75 हमने इसमें क्या नाम है ऊपर इसमें यहाँ पर शो किया हुआ है सर, ये हमने वो पुराने मेथड से फाइंड किया है ना?
No, we didn't find it from the old method. We did it from this method. For example, this is one ordinate, and for 4 meter, the triangle, the ordinate is 1. And what will be my ordinate for 1 meter? This one. It will be 1 is equal to 4x, so x is equal to 0.25. Okay, so this is how we did. I told you that that question is completed. This is completely a new method or a quick method. So
sir?
now, yeah.
सर मैं आपसे पूछना था कि आपने जो दो लाइंस एक्सटेंड की थी सर वो वन कहते हैं उस बेसिस पे किया ना कि जो आपका जो यूनिट लोड है वो किस पॉइंट पे लगा हुआ है ना?
Not on that basis really, but just on the basis that on the left support to that point. For example, my point is this C point, and on the left support of this C point, I will plot one ordinate, and on the right point, because if I would consider that unit load concept, that then on the both sides I have to show in the same direction, either in the downward or in the upward. So basically, it's just a empirical method or the method based on the experience. So you have to just know the steps to do it. On the left side, plot one ordinate. On the right side, plot -1, and then simply plot the parallel lines.
So thank you, sir.
Okay. So let us do it for the bending moment as well. Or I will use the black. For example, for the same beam, if I have to plot the ILD for bending moment at the same point, let's say C point, this distance was 3 meters and this distance was 1 meter. So now this method says that on the left support to this point, you will plot an ordinate equal to this length. The length is 3 meters. So let's say this ordinate is 3. And on the right side, you will also plot one ordinate equal to this length, that is 1 meter. Okay, and then you will plot two intersecting lines which will pass through the support. Let me show you how will. This is 1 and this is 3. So I will plot two lines which will pass through these supports. And here also this line which will pass through this support. Now, actually this point is right above this C point, or let me move my C point. This point is right above this C point. Okay, so this distance is 1 meter. So now this method says that after you have plotted these two intersecting lines, you will remove the extended portion that are on the either side of this point of intersection, and the remaining shape will be the shape of your ILD for bending moment. Let's say this shape. Now the remaining shape will be the shape of ILD, and you will remove this. Now can anyone give me this component? So for 4 meter, the component is 1. So what will be the component for 3 meter? I'm considering this triangle. This triangle, for 4 meter distance, the component is 1. For 3 meter, what will be the value?
0.75.
0.75. So now you have got one value, and by solving the simple triangle, you will get these two values as well. So this is another quick method to plot the bending moment for any kind of beam. But again, I leave it to you to try it for other type of beams and see whether it works or not. Yes.
Excuse me, sir.
Yes.
सर जिस तरह हमने लास्ट लेक्चर में एक क्वेश्चन किया था जहाँ पे राइट साइड पे दो सपोर्ट्स आ गई थी, वो सेक्शन ही बिल्कुल फिक्स हो गया था और सिर्फ
Yes.
राइट और जो लेफ्ट साइड वाला था वो पूरा का पूरा ही मूव कर जाता, उधर सपोर्ट नहीं थी। अगर उस तरह का कोई क्वेश्चन आ जाए,
So I leave it up to you to try this method.
ओके सर।
Okay. So try it and let me know.
ओके सर।
So this basically actually this is just an empirical method, and I am not giving you this as the final method, but I just told you for your practice. So try solving it for basically you just stick to these methods that we have already discussed in the class, and after getting the answer from this method, try to apply these two methods for reaction and bending moment and compare whether you are getting the same answers or not. Okay. So this basically concludes our lecture for today, and if you have any question you can ask me now.
सर इस मेथड से रिएक्शंस भी फाइंड कर सकते हैं?
What?
जो मेथड आपने बताया है शॉर्टकट, इससे हम ILD फॉर रिएक्शन भी फाइंड कर सकते हैं या नहीं?
Actually, for ILD for reaction, I think you were the one who answered that question. Yeah, I didn't show you this in this one. For ILD for reaction, the quick method is in the last lecture you gave the answer that I told you that at the support for which we are plotting the reaction, the value is always 1, right?
Yes, sir.
And on the other support, the value is always 0. So for reaction, you already have a quick method. So you know the value is 1 for this one, and you can get the components for other ordinates.
Right.
Right? So this is the quick method for reaction.
Sir?
So, yes.
अच्छा नहीं कुछ सर कोई वो आखिर में पूछ रहा हूँ सर।
Okay, the lecture is concluded. You can ask me.
अच्छा सर, I wanted to ask के जो हमारे assignments हैं उनका
Yes.
कोई प्रॉपर प्रोसीजर है जिसको हम लोगों ने फॉलो करना है या फिर बस हम स्कैन करके उनको अपलोड कर दिया करें?
Whichever you feel comfortable. I think it's better to scan and make a PDF and upload or send you.
All right, sir. Thank you.
Okay.
Yes, sir.
Or even if you can't scan, just take the pictures that are clear enough to read.
सही हो गया sir. Thank you.
Okay. So, any other question? No? So, this concludes our lecture, and if try to solve some example problems or try to solve all the problems that we have solved in the class at least, and then even if you feel confused, just send me a message or we can discuss about that. So, thank you for your time, and